Greetings. Today, in follow-up to my previous video, what I've got here is what I was thinking about yesterday. So I wanted to have a look at the plasma discharge under a microscope, because what is cooler than looking at high frequency plasma discharge under a microscope, right? So what the plasma in this, as shown yesterday in the previous video, which I'll put it in the description link for it, it gets really hot, extremely hot, so hot in fact it will melt, so the copper wire gets red hot and whatnot. So I can't put it under a microscope because that will get destroyed, because the microscope's focal length is so small that I will need to be right above the arc. So what I did over here, and I just did a little test of it, is I took two microscope slides, and they are held just with 4 magnets, 2 on each side, 1 then underneath, and in between I've laid a piece of insulated wire just to act as a spacer, so I've got a cavity in the middle, and that basically constrains the heat to here. Now this will protect the microscope to some degree, but it will allow us to see to look at the discharge arc. Now the drawback of this is evident here. So this is the remains of one of the microscope slides that I was just testing this with, and it just shattered from the heat after roughly about 20-25 seconds of arc discharge. So I think, because I haven't got too many of those left, there's only a few left in my box. So what I think, if I minimize the arcing to maybe 10-15 seconds at a time, I'll be able to have some take some good shots of it, and yeah, and see how does that look like in high magnification. So before I put it on the microscope, let me just power this whole thing up. So again, this is the same driver as let me just zoom out so you can see. So this is the same driver as in the previous video. This is just a cold cathode tube driver from the scanner that I took apart, and this is, by the way, the image sensor from that scanner, which I'll put later on under a microscope, and that's gets given 12 volt ish to power this up, and this basically goes into the copper electrodes. So I'm aware that this may get really painful if I touch stuff with my bare hands. So yeah, I will be using insulated tweezers to manipulate the wire, and just to get the arc going to begin with, because it does require me some touching the arc first, and see how that goes. So let me first zoom in as high as I can on this camera, and I'll do a quick demonstration, then we'll put it under a microscope. Okay, there we go. This is as far as the zoom goes on this camera. Mind you, the camera itself is losing the focus a little bit at this magnification, but anyways, this is just going to be a test. So I'm going to power this up. It's getting roughly about 13 volts. There we go. So this is what we're going to do under a microscope, and see what that looks like, because I can get quite a bit higher magnification on that. Okay, this is the setup, so I think I got it right. I'm just being slightly aware of the cables and the high voltage where it goes. I don't want it to kill my microscope and my phone that's connected to that microscope. That will be very upsetting. But what you see here on the screen, and I'm going to start recording this, and I'll just blow up the picture when I edit this. Okay, I think I got this right now. So yeah, that's recording now. And by the way, on the screen you can see it's the wire that comes in from the top. I've got the slide top to bottom under the microscope, and I can just about manipulate and move the lower cable just to initiate the arc. So what I'll do now is switch on the power supply and output on. So yeah, nothing broke just yet. So okay, I lost the camera for a moment. Okay, that was a little bit. I can smell a little bit of ozone in the air. I had to stop the recording because yeah, I might just crack the glass, and when I crack the glass, that'll be it for this. Okay, let's maybe move this down a little bit. Okay, output on. It actually makes everything go crazy. Makes the camera attach and detach. So no, I had to stop it. I'll give a little blow to the microscope slides so they cool down. I hope it's still recording, because every time I switch it on, the camera just stops recording. This is the plasma light, and it's creating some interesting image. Something's happening with the glass. I'm not sure what that is, but was it? Was it eroding the glass? Yeah, certainly. So it was causing some interesting damage to the glass. So maybe that's what caused the crack beforehand. And this is why the wire starts. So it's right on the side of, hold on, which one's, on one of the electrodes. Well, it's AC, so there's no positive negative, but certainly there is there appears to be some sort of polarity effect on here. But anyways, perhaps what I should do is move the electrode to a slightly different spot. So if this is causing the glass to crack, so maybe we'll get a bit more life out of the microscope slide. Sorry for the delay. Your usual program will be resumed in a moment. Okay, there we go. And one more time, output on. And I've lost the image again. I think I should get a slightly better resolution camera to then I'll be able to resolve a little bit more, because right now this seems a bit of a blur. I'm trying to move the microscope up and down to catch the focus, but it's really difficult, so maybe maybe if I move it to where the cable is, there we go. Yes, I was completely out of whack. No, not ideal. There is some interesting light effects on here, and copper is getting really hot, I can see already, so maybe I should stop this for a moment. I hope this is still recording. It certainly shows us as recording. Maybe I'll stop and start again. This is causing everything I've got on here to go haywire. So let's start recording again, and we'll do one more. We'll have one more go at this. Now we won't be able to focus on the actual plasma. It's the microscope hasn't got enough resolution. You can just about see it wiggling around a piece of copper, and that's about it. But nonetheless, it looks quite interesting. I can see the erosion is taking place again in that corner. Well, I'm not sure if I'll be able to catch that on. Anyways, that was somewhat interesting. And a little bit disappointed that let me just switch the power supply off. There we go, quiet again. A little bit disappointing with the performance of the microscope and my stand setup. I think I've got to modify this a little bit so it's a little bit more stable, because it wiggles a little bit too much when moving it around. Yeah, that was the high frequency plasma under a microscope, for whatever that made. And yeah, once if I'll manage to get a better microscope, I'll definitely revisit this. I should stop recording now. I hope it all recorded. Yeah, while I've got the setup going, let me place this under a microscope and we'll have a quick look at how it looks. Okay, so yeah, I've got this centered on the edge on one side of the chip, and I'm just gonna start recording on here, and I'll try to talk through as I go through what I'm saying. So there is, as seen before in my previous video, you could see that there was 3 lines separate for each color, and here is just 3 dots. There's actually 4 lines, so there's one that seems to be white, one blue, red and green. Those squares over here are purely for alignment, and as I move inwards towards the center of the chip, there is this structure which I can't make up of what is this supposed to be. Clearly it does something. Anyway, but as we move along, in opposite order as the marks used for alignment, we've got the red, green, blue and white at the bottom, and red, green and blue stripes, well, we call them detector stripes, have got 3 visible lines, and the white one seems to have 1. And I think this stopped recording, so let me just stop and restart. There we go. So yeah, the program stopped recording somewhat, but yeah, let's move along the chip, and this is just a really long strip that goes across the whole chip. So maybe to save us from sliding across the whole thing, because that will take a couple of minutes, let me just manually move the chip over to the other side. and get it somewhat centered. There we go, yeah, we can work with that. And let's move it now towards the end. It shouldn't be that long. There we go. And we'll see. This side has got a little bit different structure. So this silicone on here seems to be a bit more beefy than the other side. The tracks are thicker, and there is a clear pattern emerging for each separate line. There seems to be the same thing. There's 1, 2, 3, 4. Well, there's actually five lines going across, plus a number of thinner lines going somewhere towards the left. And here's bond wires. Just you can see those have been just melted on onto the pads. It's probably done through ultrasonic. Anyways, moving on towards the end, let me just go up a little bit. Oops, wrong button. Oh yeah, that's the edge of the chip. So there it is. Which is a strange arrangement of those lines that go top to bottom. I don't quite understand what those are. But all this stuff over here is probably some sort of transistor arrays, or perhaps resistor arrays for powering this up. Maybe memory cells, but everything I'm saying, it's a pure guess. I have no idea. So let me just stop recording. Yeah, so there we go. That's the chip from the scanner. I guess this whole thing is a bit like a digital camera sensor, but yeah, it's just got one line with really long one row of pixels for each color to get the image. And as the whole assembly was moving across the piece of paper, it would have scanned it line by line. So yeah, that's all for this video, I guess. If you liked it, I hope it turned out okay, because the camera was switching off with the high voltage and high frequency stuff going on. But yeah, if you like the video, please do click like or subscribe for more random stuff. I should be making some. And as far as this one, I think that's it. Take care.